Bismillahirrahmanirrahim. Assalamu alaikum, my dear student. I am Yasin Mahmood. I hope you all will be fine and enjoying good health. Dear student, today we are going to discuss about the electricity. Firstly, we will discuss about the static electricity. Now, what is the static electricity? It is a branch of physics that studies the electric charges at rest. Dear students, static means rest. Mean if we discuss about those charges, then the study of the charge is called the electrostatics. Dear student, you must have to know about the charge. What is the charge? Charge is the intrinsic property of a body due to which it can attract or repel another charged body. Here intrinsic means natural, pure. Mean charge is basically the natural property of a body due to which it can attract or repel another body. That is called the charge. The SI unit of the charge is coulomb. That's the name of the scientist. So my dear student, because the concept of the charge is given by the coulomb, that's why the SI unit of the charge is coulomb. Symbolically, it is represented by capital C. Now, next, the types of the charges. We know that there are two types of the charges. One is negative charge, other is positive charge. What are the positive negative charge? An object becomes negatively charged when some electron are placed on it. When we place some electron on an object, it will become negatively charged. On the other hand, what are the positive charges? An object becomes positively charged when some electrons are taken from it. Mean when we take some electron out of the object, that become a positive charge. And when we place some electron into the object, that will become negative charge. Clear, my dear student? When we place some electron on an object, it will become negative charge. And when we take some electron out of the object, it will become positive charge. Next is the electric force. What is the electric force? The attractive or repulsive interaction between the two charge object is called electric force. Dear student, whenever two charges are present, they always exert some kind of the force on each other. That force is called the electric force. And that force may be attractive and may be repulsive. First of all, we see when the force will be attractive, the force between the two unlike charges will be the attractive force. Here unlike means if the charges have an opposite nature. Opposite nature means if the one charge is positive, other must be negative. If the one is negative, other must be positive. That is the opposite nature. And the force between these opposite charges are the force of attraction. Now on the other hand, what are the force of repulsion? Force of repulsion is the force between the two like charges. If the both charges are like charges, means both are positive or both are negative, then the force between them will be the repulsive force, force of repulsion. Okay, my dear student, clear what is the attraction, what is the repulsion? Now, next is the electric field. What is the electric field? The space or region around a charge in which it can exert force on other charge bodies called the electric field. Dear student, one thing you must be kept into your mind. Whenever there is a charge placed on any charge placed on any object or at anywhere, it always create a region around it. It always create a space around it. That region or that space which is formed around the charge is called the electric field. And when we place any object into the electric field of that charge, it always exert force on that object. Okay, my dear student, clear? What is the electric field? Electric field basically the region or the space around the charge in which that charge exert the force on another charge which is placed in that electric field. That is called the electric field. Now, dear student, let's suppose this is a positive charge and the region around this positive charge electric field which is shown by the lines. As I shown by the lines, these lines are representing the electric field of that charge, positive charge q. Okay, beta. That positive charge representing the region or space around it, that is called the electric field. Now what are the electric field lines? The imaginary lines which are used to represent the electric field called the electric field line. Dear student, As I told you that there is always some kind of the space or region around the charge that is called the electric field. Now there is always some kind of the mechanism to represent that electric field. How we can represent that electric field? How we can represent a charge is creating an electric field? We can represent it by the imaginary lines. We will draw the lines. Dear student, one thing you must be kept into your mind, these lines are imaginary, not real. In reality, charges not form lines, not form electric field lines. Electric field lines is only used for visual representation of the electric field. Okay, my dear student, it's only described about the presence of the electric field, whether the electric field are present or not. It is represented by the electric field. Dear student, another advantage of electric field line, that the electric field lines not only tell us the presence of the electric field, it also tell us about the strength of the electric field. Mean at what place electric field is stronger and what place electric field is weaker. Let's suppose we take a positive charge. Dear student, the electric field lines formed by the positive charge is always directed outward as shown in the figure. We can see that these are the electric field lines which is formed by this positive charge. A direction is in outward direction. You can see that it always directed outward. Now the electric field lines which is formed by the negative charge, its direction is always inward. Look at this. These are the electric field lines which is formed by this negative charge. Look at its direction. It is inward. It always in the inward direction. Dear student, as I told you that electric field lines also tell us about the strength of electric field. How? Look at this. Dear student, at that point, the gap between the lines is very small, but at that point, gap between the lines is very large. Dear student, one thing you must be kept into your mind: if the field lines are very close to each other, then at that point, electric field will be stronger. And if the field lines are further apart from each other, then at that point electric field will be weaker. You can see that at that point two lines are closest to each other, means the strongest electric field will be at that point. But at that point two lines are further apart from each other, so weakest electric field at that point, that is the strongest. At that point strongest electric field, at that point weakest electric field. Similarly, at that point electric will be strongest, and at that point will be the weakest. Okay, my dear student, that's how we can represent the electric field and electric field strength by means of the electric field lines. Now take some other examples. If we take the two like charges, how the electric field lines will be formed? Look at this. We have taken the two charges of same nature, though both are positive charge. You can see that the electric field is formed like a curved shape, curved lines, because because every charge repelling another charge, this charge is repelling this charge, and this charge is repelling this charge. So as a result, the field lines form in outward direction. You can see the direction is outward. And whenever two charges of same nature brought closer to each other, they always form a region that is called the field free region. This is called the field free region, the region in which no electric field is formed. Okay, my dear student, at that point, at that region, there is no electric field. That is called the field free region. And it only formed when we take two charges of the same nature and brought closer to each other. They always form field free region between the two charges. That field free region means that there is no electric field at that point. Now take another example, the electric field lines between the two unlike charges. As we discussed that the electric field between the two unlike charges, the electric force between the two unlike charges will be the attractive force. It means that when we place two unlike charges very close to each other, they always attract each other. You can see from this figure that the field lines are moving or attracting towards each other. And one important point, electric field lines always start from positive charge and end on a negative charge. Okay, my dear student. You always start the flow, the motion of the electric field line from positive charge towards the negative charge, not from negative to positive. It's positive to negative. You can see that the direction that is from positive to negative, and they are attracting each other. Okay, my dear student. Mean whenever the electric field line is formed between the two like charges, they always repel each other and they form a curved shape. The lines will be in a curved shape and they also form the field free region between the two charges. That field free region means there is no electric field between the two charges. And when we want to represent the electric field lines between the two unlike charges, as we know that unlike charge will attract each other, therefore their electric field lines will be in attractive one. They will attract each other and it always originate from positive charge and end on the negative charge. Okay, my dear student, that's it for today's lecture. See you next time. Okay, dear student, take care. Allah Hafiz.